because you're still cheating. All right, guys, we're going to talk about the sine, cosine, and tangent ratios today. Okay, we are going to talk a little bit about trigonometry. We are just going to dip our big toe into the trigonometry pool today.
So trig just means triangle, basically.
It's the study of properties of triangles. Okay, a trigonometric ratio is a ratio of the measures of two sides of a right triangle. This is important. We need a right triangle. So we need a 90-degree angle in our triangle. Okay, using trigonometric ratios, we can find unknown measures of angles and sides of right triangles. So, the sine of an angle is defined as the ratio of the length of the leg opposite the angle and compared to the length of the hypotenuse. So if I'm taking for this angle, A, do you see how this side over here is opposite A? And C is the hypotenuse. So that would be A is the opposite side and C is the hypotenuse. Does everybody see it?
Why is C a hypotenuse?
Because it's the longest side. It's across from the 90-degree angle. So the legs are the short sides and the hypotenuse is the long side across from the right angle. Everybody okay with that? Okay. So the sine of B, the hypotenuse is still the hypotenuse, but opposite angle B is side B. You see that? So depending on which side we're talking about, the opposite side will depend on that side. Yeah. Be my guest. Okay, now we're going to look at the adjacent. Okay, the cosine of an angle is the adjacent leg over the hypotenuse. So if I look back starting at A, angle A, adjacent to angle A is not side A, it's side B. Do you see that this one is the adjacent side? Adjacent means next to, right? Okay, so B is next to A, and you put that over the hypotenuse, so it's B over C. Everybody all right with that? Okay, the next one is the tangent. So if I look at my angle A, it's opposite over adjacent. So it's A over B. Okay? If I switch my angle that I'm starting from, if I'm looking at the tangent of angle B, B is the opposite. And side A is the adjacent. Does everybody see how that changes depending on which angle I'm talking about? Okay, perfect. All right, so this is a helpful little device that can help you remember sine, cosine, and tangent and the ratio. So this is your sine. It is opposite over hypotenuse. Okay, cosine is adjacent over hypotenuse. Whoops, that's not how you spell it. Okay, tangent is opposite over adjacent. Okay, so when people talk about SOHCAHTOA, this is what they're talking about. It's just a device to help you remember the names of the ratios and then which sides comprise those ratios. So far, so good? Okay. Let's look at a couple of examples. All right, so we're starting from angle A. So cosine of A, we want adjacent over hypotenuse. So if I'm looking at angle A, the longest side is always the hypotenuse. So I used to get confused sometimes when I was a kid and try to make the 16 the adjacent. The 16 can't be the adjacent because its job is hypotenuse. Does that make sense to everybody? Okay, so this is the hypotenuse. Which side is adjacent to angle A? Adjacent, not opposite. Next to it. The 8 root 3, right? So this is the adjacent. So I put that over the 16. So I do 8 root 3 over 16. Now do you see that we have a common factor? Yes, the common factor is 8. So if I divide the top and the bottom by 8, what do I get? 1 root 3, which is root 3 over 2. Everybody see how we got that? 8 divided by 8 is 1. 16 divided by 8 is 2. Okay. That's it. All right, now let's do the cosine of B. Okay, the hypotenuse is still the hypotenuse, but we're going to start from this angle. Which side is adjacent to angle B? It's the 8. This is now the adjacent side. So now I'm going to take 8 over 16. What does that reduce to? 1/2. Okay, now we're back to A. Start with my angle A. Tangent is the opposite over adjacent. So the hypotenuse is always the hypotenuse. Do we need him right now? No, we need the opposite and the adjacent.
Would be 8 over 8.
8 over 8 root 3. Good. Now, we have to reduce that. Can we divide out the 8?
Yeah.
Okay. So that gives us 1 over root 3. Now, this next thing is something that you haven't ever seen before, but it's not hard. We used to do it in Algebra 1. So this is something that if we had done it in Algebra 1, your Algebra 1 brain could have handled. Okay? So this is called rationalizing the denominator. It is very bad math manners to leave a radical in the denominator. We want it in the numerator. So we are going to do something called rationalizing the denominator. Remember that we are allowed to multiply by 1, and it doesn't change our fraction, right? It just changes the way it looks. So if I multiply by 1, and on the top of my 1, I put a root 3, and on the bottom of my 1, I put a root 3. Root 3 over root 3 is 1, right? So now 1 times root 3 is root 3. What's root 3 times root 3? Oh, Robert knows. He's in algebra 2. Tell us. What?
You're not algebra 2?
Oh, I thought you were raising your hand. Yeah, he is.
Actually?
Yeah.
You're not allowed.
Sorry, I blew your cover.
Wait, are you? Yeah, I'm smart.
Okay.
Smart enough more? Did you fail this class last year?
No, he's taking them at the same time. He's doing great. Okay, what's root 3 times root 3? Okay, so what is the square root of 3 squared? What happens? What does squaring undo? Undoes square root, right? It's just 3.
But then now you have 1 on the top.
Yeah, that's okay. That is less offensive. Okay, so we have to rationalize the denominator.
Wait, how did we get that it was 3 over 3? Like the square root of 3 over 3?
Okay, I can show you again at the end, but we got to keep it moving.
Okay.
All right, what about the tangent of B? Okay, that changes which one is opposite and adjacent. So if I look at B, the 8 over the 8 root 3 is the opposite, and the 8 is the adjacent. So I would do 8 root 3 over 8, reduce it. What do you get? Yeah, just root 3. Right? The 8's cancel. Or the 8's simplify to 1. And then 1 times root 3 is just root 3. Any questions? Do we need to talk about rationalizing the denominator and pause the video for a second? All right, guys, now we're going to talk about calculators. Okay, let's talk about settings in your calculator. For right now, guys, your calculator must be in degree mode if we're doing problems in degrees. Okay, there's another mode called radians, and that's something that you're going to learn more about when you get into your upper level math classes. Okay, unfortunately, your calculator's default setting is radians. So anytime the memory gets reset or anything like that, it's going to go back to radians. Anytime, someone in pre-calc uses it, they're going to put it in radians. What?
Is calc hard?
Yes. All right.
What is it though? Is it like
Not right now, bro.
Just answer my question.
No. Okay. Go to your calculator. Go to mode.
Wait, whoa.
Go to mode. Okay, do you see that right now my cursor is on radians? It's highlighted in black. So I have to arrow down and go over to degrees and hit enter on degree mode. Okay, does everybody know how to do it? Okay. Okay, we're going to use our calculators. All right, these are going to be easy. So we're just going to use the calculator to figure out these ratios. We're going to round to the nearest tenth. Okay, so that would be 1 point beyond the decimal. All right, we want the sine of 52 degrees. Okay, so we're in degree mode. Second mode to quit. Does everybody see the sine button right here? Okay, sine 52. Close parentheses, enter. Okay, so to the nearest tenth, that's 0.8. What's up? Okay, cosine of 19. Okay, I'm getting 0.9. I'm getting 0.9. Okay, tangent of 65 degrees. Tan 65. 2.1 is correct. Okay, what about tangent of 11?
22.
Yep. Okay, sine of 62. 0.9, 0.9. And cosine of 30.
0.9.
Also 0.9. I wanted to see 0. Okay. What do you notice about all of the sines and cosines?
For all degrees.
What do you notice about how big they are?
Some of them are.
Are any of them bigger than 1?
Yeah.
No. Sines and cosines, not tangents.
No.
Did you see that all of the sines and cosines are like less than 1? Okay, think about it. If you're either putting the opposite or the adjacent over the hypotenuse, and the hypotenuse is the long side, right? So we're putting the big number in the denominator. You guys see that, well, it always has to be like smaller than 1. You guys see why they're little? Okay. It's only when we get a tangent ratio that we can have something like 2.1, where we can have a bigger number on top in the numerator. Is that okay with everybody? Okay. Let's go on to the next part. The hypotenuse is always the longest side of a right triangle. Thank you, we already knew that. So the denominator of a sine or cosine ratio is always greater than the numerator. Therefore, the sine and cosine of an acute angle are always positive numbers less than 1. Since the tangent of an acute angle is the ratio of the lengths of the legs, it can have any value greater than 0. All right, so we're going to find these lengths. Okay.
I know one.
We're trying to find the length of BC. Can we call that X? Okay, so look at my labeled information. Okay? Do you see that I have a 15-degree angle B? Okay? With respect to that angle, do you see that the 10.2 side is the opposite? And the X is the adjacent. Everybody okay with that? And this one's the hypotenuse, but I'm not going to use it because I don't know anything about it. Okay, which of my ratios relates the opposite and adjacent?
What did you say?
TOA. Opposite and adjacent. Which, no, listen. Which of my ratios, sine, cosine, or tangent, uses opposite and adjacent? Tangent. Okay, so this is how you set up your equation. You look for what information you have, and then you're going to use that ratio. So I'm going to say tangent of 15 degrees equals opposite over adjacent. Which one is the opposite? The 10.2. Good. So I'm going to say 10.2 over x. Okay. There's a little algebraic trick I'm going to show you guys real quick. Do you guys know that 3 is 12 divided by 4? Right? Could I also say that 4 is 12 divided by 3? Okay. So if you have an equation like this that has fractions, and like 3 over 1 and 4 over 1 are fractions, what you are allowed to do, people, is switch these two numbers on a diagonal. Think about it. Do we need to see why real quick? We need to see why real quick? You just want to believe me?
Yeah.
Okay, so I can show you after the video if you're curious. Okay, so do you see right now that my x is in the denominator? When you're solving for a variable, you do not want that variable in your denominator. You want it in the numerator. So can I use this trick to move my x into the numerator by switching spots? Yes. So I'm going to say x equals 10.2 divided by the tangent of 15 degrees. Okay, your calculator knows what the tangent of 15 degrees is, so we're going to use it. So we do 10.2
Didn't get that wrote down, by the way.
divided by tangent of 15 degrees. I'm getting 38.1. Are we still rounding to the nearest tenth?
Is that correct,
Yeah.
Robert? Robert, is that correct? Yeah. Good, Robert.
So 38.1. 38.1 feet. All right, let's try another one. All right, do you guys see that they gave us angle P?
Yep.
Okay, what are they asking us to find? QR is going to be our x. Is the x the hypotenuse?
No.
Okay. So with respect to angle P, is it the opposite or the adjacent? Okay, this is the opposite. And what is the 12.9? No? It's the long side, so it's the hypotenuse. Okay, so I'm going to say, which of my ratios uses the opposite and hypotenuse? Sine, cosine, or tangent? Sine, yeah. So we're going to say sine of 63 degrees equals, put the x on top because it's the opposite, over the hypotenuse, 12.9. Okay, my calculator knows what the sine of 63 degrees is. It's smarter than me. So all I have to do is undo dividing by 12.9. How do I undo dividing by 12.9? I multiply. So my x is just going to be 12.9 times the sine of, oh my God, sine of 63 degrees. Okay, let's put that in the calculator. 12.9 times the sine of 63 degrees. I'm getting 11.5. This appears to be centimeters. Okay. Now we're going to find the length of FD. So FD is going to be our x.
That's the hypotenuse, correct?
It is the hypotenuse. Good.
Right.
Shut up.
Hey, I say great job.
Okay, we're going to act like that was sincere and say thank you and move on.
It was not sincere.
We're
I
gonna-
can tell it was not sincere.
Okay, so do I know anything about the opposite side? No, so I'm not going to use that one. What do I do? What do I know? Adjacent side, right? Okay, so which of my ratios uses adjacent and hypotenuse? SOHCAHTOA. Cosine. We have adjacent and hypotenuse.
Yeah, what
So
was that saying?
SOHCAHTOA.
What is that?
You were in the bathroom. I'll tell you in a minute. Okay, so cosine of 39 degrees equals adjacent over hypotenuse. Don't put that x on top. 20 over x. Okay, what's the little algebra trick we learned today? If our x is in the denominator and we don't want it under there, we can switch it along the diagonal. Remember? Okay, 3 equals 12 divided by 4, and 4 equals 12 divided by 3. So I get x equals 20 divided by cosine of 39 degrees. Pop it in your calculator. What was it, 39?
Yeah.
I'm getting 25.7. 25.7 meters. Okay, do you guys think you can do number 6?
No.
No?
No.
Okay, we're going to find the length of DF. So DF is our X. Okay, we know angle D. Okay, how am I going to label this triangle? What do I label the X? Hypotenuse. Very nice. Okay, what about the 17?
Thank you. Hey, I actually complimented him and he wanted to say
Okay, is it opposite or adjacent? Yeah. Opposite. Okay, which of our ratios uses opposite and hypotenuse? Fine. So do you see how the information that we're given tells us which ratio to use? Okay, like you wouldn't want to use cosine on this because we don't have anything about the adjacent side. We have to use sine. Everybody okay with that? All right, so sine of 51 degrees equals opposite over hypotenuse. So 17 over x. Okay, algebra trick. Switch along the diagonal. So x equals 17 divided by sine of 51 degrees. 17, was it 17? I already forgot. Oh my gosh, I shouldn't have drank all that Diet Coke in my 20s and 30s. 17, yeah, divided by sine of 51. I'm getting 21.9.
Perfect. Do we have study time now? 'Cause,
Let's look. This should be meters. Don't forget your units.